Today, we're going to talk about texture maps. Let's go. Texture maps are images that we apply to the surface of our 3D models to give them details that wouldn't otherwise be there. So here in Unreal 5, I have a simple shader with a bunch of different texture maps applied. You can see that my model appears to be made of a cobblestone material. If I switch the preview window to wireframe, you can see that my model is just a very simple cube. But with the texture maps applied, it looks like there's a ton of detail on the surface. The detail is all coming from the texture maps. We can use texture maps to represent lots of different types of surface information or properties of the material. So switching back into Photoshop here, you can see that I have a texture that represents the color of the cobblestones on the surface. This texture represents the roughness of the surface. This is our specular texture that represents how reflective or shiny the surface is. This is our ambient occlusion texture that represents how much the object shadows itself. And then this is our normal map that describes the shape of the surface. Instead of representing color, each of these pixels represents the direction that that pixel is facing. If you want to learn more details about what each of these textures does, take a look at this video that I created previously about physically based rendering. Before we get too deep into the details here, let's step back a bit and look at the big picture of the process of creating textures and bringing them into the engine. In the process of creating 3D graphics, there are three main categories or types of texture files. First, we start with our source files. We create textures in apps like Photoshop, Substance Designer, Substance Painter, and Quixel Bridge. I actually created my cobblestones textures by modeling them in 3ds Max and then rendering out the images. So our first category is source files. These files can be really large, and the data is almost always stored uncompressed. This is where you create your original images and where you make edits if you need to adjust things. From here, we export our textures to an intermediate or raw format. If our images are coming from Photoshop, all the layers and masks are flattened down to a single image. Targa or TGA files and PNG or PNG files are the most common formats used for these raw images. These formats are used because they're small, high quality, and support the use of red, green, and blue channels, as well as an alpha channel for storing additional data. While these files are smaller than your source files, they're not compressed and not stored in a format that's natively supported by the graphics card. So, to be able to use them in the game, we need to import them into the game engine. But before we go on, it's important to remember not to edit your files at this raw or intermediate stage. If you need to make adjustments, go back to the source files and make your changes there. Then re-export to the raw image file formats. Editing the raw files directly makes the source files obsolete and significantly limits the types of changes you can make going forward. Alright, so when you import a texture into the engine, a third texture asset is created, and this is the in-game version of the texture. The engine automatically creates this texture asset. Here I'm representing this asset with the DDS icon, because DDS or Direct Draw Surface files are used by DirectX platforms such as Windows and Xbox. But other platforms such as Apple devices, Android, and PlayStation all use their own proprietary image formats. The game engine automatically creates these for you when you import your texture. These images are stored in a specialized compression format that is natively supported by the graphics memory and the GPU on your target platform. They're as small as possible, so they take up as little memory as possible. And the game engine has a few simple tools for adjusting textures at this stage, but again, generally, if you want to make adjustments, you want to go back to your source files and make adjustments there, then re-export your raw and re-import them into the game engine. So, there are a couple of key takeaways from understanding these three types of files. First, as we talked about, you want to make edits to your textures in the source files, then export them to the raw format, then import them into the game engine. And second, when we talked about how much texture memory a texture is using, we're not concerned at all about how large the source files are, and we don't care how large the raw files are either. These are not what's being used in the game or loaded into graphics memory. The only thing we care about is the size of these final image formats that the game engine creates. In the comments for past videos, I've had people confused about this. They were looking at the size of their TGA files in Windows Explorer and worried that their textures were that large in graphics memory. Nope, we don't care about how big our source or raw files are. So, let me show you in both Unreal 5 and in Unity how to see the final size of the in-game versions of your textures. Alright, so here we are in Unreal 5 in my scene, and I'm going to come down here to the lower left-hand corner and click on Content Drawer to pop up the browser that shows all of the content in my game. So I'm going to come here to the Textures folder and find my Cobblestones D texture. This is the one that we were looking at in Photoshop a minute ago. So I'm just going to double click on this to open it. And you can see I've created a new tab, or it's opened a new tab here with Cobblestones D. So this is a version of the texture that was automatically created when I imported the TGA or Targa file into Unreal. And you can see down here at the bottom it says source file, and this is where the Targa file is located on my disk. So if I click here to browse for the file, it'll open up all of the files that I have in this particular directory, and you can see here that my Targa file is 12 megabytes. My source Photoshop file is almost 60 megabytes, so going from source to raw, because this version of the file has a bunch of different layers in it, it's 60 megs. Going to raw, I've reduced the layers down to 12 megabytes, so you can see that raw TGA file is quite a bit smaller than the source file. But again, I'm not concerned with the file size of these at all. What I really want to look at is once I import this texture into Unreal, I can come up here under the Details panel and look at this asset here where it says Resource Size 2,752 kilobytes. Well, what that means is that my final compressed in-engine version of the texture is just 2.75 megabytes of space. So I went from my source file being 60 megabytes to my raw file being 12, and now the asset that actually fits into texture memory in the graphics card on my PC or on whatever other platform I'm running the game on is just a little under 3 megabytes. So there's a massive amount of reduction that goes from my source file to my actual in-game file. And the only size that we're actually concerned with is this resource size right here. All right, I hope that's clear. Let's switch over to Unity and I'll show you where to find it there. All right, so here we are in Unity, and similar to Unreal, I have an asset browser here with all the different types of assets in the engine. I'm going to come over here to Textures General. This is where I've imported my textures, and I can select a texture and right click on it and pick Properties, and that's going to bring up this panel that allows me to set all these different settings on the texture, similar to what I was doing in Unreal. We'll go over these other settings in a minute, but what I want you to do is take a look right down here at the bottom. It says my texture is 2048 by 2048, RGB compressed, and it says the size is 2.7 megabytes. So just like Unreal, I've compressed my texture down and gotten it from 12 megabytes in the raw format to 2.7 megabytes in the compressed format. So this is the value that we're concerned with, and when we talk about compressing our textures, this is the size that we want to look at. At this point, you're probably wondering how you can control the amount of memory your textures use. Let me show you how that works. First, and most obvious, texture space can be controlled by the dimensions of the texture or the texture's resolution. Second, the number of channels that the texture uses affect the size, and third, the type of compression you use is also an important factor in the size of the texture. So to help you understand this a bit better, I put together this table. Down the left side, I've listed the most common texture sizes. And to be clear, this is the size of both dimensions. So 64 means 64 pixels in height and in width. Notice that the texture resolutions are powers of 2, 64, 128, 256, and so on. These sizes are the most efficient because they fit into memory really well. So textures are commonly stored as powers of 2. Across the top of the table, I've listed several different types of texture compression, going from DXT1 on the left, which is the most compressed, to RGBA on the right, which is no compression. DXT1 supports 3 channels, DXT5 supports 4 channels, BC7 supports 3 or 4 channels, and then RGB and RGBA are uncompressed texture formats that support 1, 3, and 4 channels, respectively. The data in the table is expressed in kilobytes, and since there are about 1,000 kilobytes in a megabyte, if you add in a decimal 3 digits from the right, you get the approximate number of megabytes. So for example, a 4096 texture using DXT1 compression takes up right around 11 megabytes. All right, so what are some key takeaways that we can learn from looking at the data in this table? First of all, dropping one resolution step, for example, from 4096 down to 2048, reduces memory by about 4 times. So we can see going from a DXT1 texture of 4096 down to 2048, it goes from almost 11 megabytes to just under 3 megabytes. What we can see from this is that using 4K textures is really expensive. We just added like 8 megabytes to jump from 2K to 4K. All right, the other thing that we can see is that if we use uncompressed textures, these textures need to be relatively low resolution. If I'm using a 4-channel texture that's uncompressed, that's 87 megabytes. And I can take a whole bunch of DXT1 textures and fit them in the same space as one uncompressed 4K texture. So I highly recommend that you not use uncompressed textures unless they're relatively low resolution. You know, if you want to make a texture that's 256 or 512, you're looking at these costs here for the texture, and those are equivalent to just slightly larger compressed versions. So if you need a texture that's really high quality that doesn't have compression artifacts, you can use uncompressed textures. Just make sure that they're not too much higher than about 512 resolution. And then our final takeaway here is that using an alpha channel doubles your memory cost. So if we're using a 1024 texture, that's DXT1, that's 704 kilobytes. But then if we add just one more channel, so it's using 4 channels, now we're up to 1408. So we've doubled our cost going from 3 channels to 4 channels. Now that 4th channel, the alpha channel, does look really nice. It doesn't have that much texture compression artifacting, but it does double the cost. So when possible, we should try to use 3 channels and instead of 4. And if you ever have an alpha channel that you're not using, you should be sure that you get rid of it so that you can use the 3-channel DXT1 compression versus the 4-channel DXT5 compression. All right, I hope that helps a little bit in your understanding. Now let's jump into both game engines and I'll show you the little knobs and dials that you have to control these settings for the textures. Alright, so here we are in Unreal, and I'm taking a look at a texture that I grabbed from Quixel Bridge. And you can see that the imported size of this texture is 4096 by 4096. Now if I want to control the resolution of the texture, I have this box here that says maximum texture size. So I can grab this. If I have this set to 0, for the texture size, it's just going to be 4096 by 4096, and you can see that the max in-game version is also 4096 by 4096. Now, if I want to limit that, I can also type in a value here. So if I type 2048, for example, now you can see it recomputes it, and my imported size is still 4096, but the max in-game version is 2048, which means that I've dropped the resource size here, the amount of texture memory that it's using, significantly. So if I go back to 0 again, you can see that my resource size is just shy of 21 megabytes. But if I reduce that down to 2048, now you can see my resource size is about 5.5 megabytes. So that made a significant difference here in Unreal when I'm limiting the size of the texture from its native 4096 to 2048. All right, so we talked about resolution a little bit. Now we can pick what kind of texture compression I want to use. Notice up here that it says format DXT5. So if we remember from our table, DXT5 is a 4-channel texture format. And if I look up here under these RGBA buttons, you can see that I do have an alpha channel. So there are 4 channels here. But if I made a mistake when I exported my texture and I didn't really mean to use that alpha channel, I can come up here to this box here, compress without alpha, and check that. And it's going to recompute. Now you can see that the format has gone from DXT5 down to DXT1. And my resource size, instead of 5.5 megs, has gone to 2.7 megs. So losing that alpha channel, if there's data in there that I know I definitely don't need, I can just check this compress without alpha. And now I'm using DXT1 to just compress 3 channels instead of 4. So that makes a big difference. All right, there are a couple of other compression settings I have here available. If I want to use uncompressed, I can use User Interface 2D RGBA. So let's pick that and see what happens. So now you can see that my format has gone to B8, G8, R8, A8, and that means I've got 4 channels. They're all using 8 bits per channel at a 2048 texture, and I'm using about 21, almost 22 megabytes of texture memory. So this is an uncompressed 4-channel texture using almost 22 megabytes. Probably not recommended because it's so big. But if you did want to store this texture as uncompressed, RGBA like this, you might be able to get away with it if you drop the maximum texture size down to 512, because now you're just under 1.5 megabytes here in resource size. Now your resolution did take a pretty big hit, so you'd need to be careful, and it's always a balancing act in video game development to balance the amount of memory you're using and the quality level versus the resolution. All right, now if you just have a single channel texture, you can pick grayscale, and you can notice this is grayscale R8, and I can turn my size back up to 2048 again. And now you can see the format has gone to G8, which means it's only storing one of the channels of my texture. This is also uncompressed, but you can see that it's only using 5.5 megabytes uncompressed because I'm only storing one channel. So if you have a type of data that fits well into one channel, you can use this grayscale option to reduce the memory if you're using uncompressed data. However, it's probably still better to go with DXT1 here if you're only using one channel and you can get away with using texture compression, because again, it goes down to 2.7 megabytes instead of 5.5. Okay, let's open up a couple of textures and take a look at some real-world examples of how I might use these. All right, first we're going to take a look at our color texture. also sometimes known as albedo or diffuse or base color. In this case, we can pretty much leave the compression settings at their default. So here I've got my compression settings at default, and it's storing it in the format of DXT1 using 2.7 megabytes of memory. One more thing that I want to mention here, we've got this box down here called sRGB, and for a color texture, this needs to be true. Color textures are stored with gamma correction applied, which is also called sRGB. So for color textures, this needs to be on, and for pretty much everything else, it should be off. I'll put a link in the description to a video that describes what linear is versus sRGB and goes into this in a little bit more depth, just so you understand. But basically, the main rule of thumb is if you're storing color, turn sRGB on, and if you're storing anything else, turn it off. All right, let's take a look at another type of data. Here we're storing a roughness texture, and the roughness is just using one channel. It's grayscale. It doesn't need red, green, and blue. It just needs grayscale or black and white. And so our compression settings, we've chosen to set it to masks, no sRGB. So we have sRGB off here. And you can see that the texture format that's being used is DXT1. Now I could use an uncompressed texture format for this, but in this case my texture is noisy enough and the compression artifacts don't really show. And so I'm able to store this in using DXT1, which makes my memory size half as much as if I were storing it in grayscale. So if I were to pick grayscale here, you can see that my size jumped up to 5.1 or 5.5 megabytes. But if I store it as masks, it jumps down to 2.7. So that's great for textures like roughness, for ambient occlusion, for specular. Those are single channel textures that can be stored as masks. All right, here's an interesting example. This is a texture that I've taken several masks and packed them all together. So in the red channel, I have my ambient occlusion. In the green channel, I have my specular. In the blue channel, I have my metalness or metallic mask, and in this case, it's just all black. And then in the alpha channel, I have my roughness. So I actually have 4 channels where each channel contains a different type of data. And you can see again, my compression settings are set to the default DXT1, 5, or BC1. And in this case, the engine has automatically selected DXT5 for my texture because it has 4 channels instead of 3. And you can see again, I've got sRGB unchecked because this data is not color data. Even though when I have all these on, it looks like color, it's just because each of these different channels is using different amounts of black and white, and they contribute to make it look like color, but it's really not. These are 4 separate data types stored in the 4 different channels. All right, let's take a look at another example. This is my height map. You can notice that this texture is relatively blurry, and because of that, I was able to save out the raw version of the texture as just 256 by 256. And you can see that for this one, I've set my compression settings to grayscale. And there's a good reason for this. Normally, instead of grayscale, like on my cobblestones texture here, I've set it to masks. Well, for this one, the texture compression actually chews it up a little bit. And let me show you what that looks like. If I set this one to masks, you can see all of these like crunchy little artifacts around the edges of the cobblestones. That's what the texture compression is doing to it. So if I did set it to masks, I could get away with 48 kilobytes. But because it's a small texture, I'm going to set it to grayscale, single channel uncompressed, and now my results are nice and smooth, and I don't have any of those same artifacts that I did with the compressed version. Now, the thing that I am giving up is resolution, but I'm able to get away with that because the texture is a little bit blurry and I don't need a whole lot of detail. All right, let's take a look at one last example. This is my normal map. And you can see that under compression settings, there's a very specific setting that's specifically for normal maps. Unreal has selected BC5 for my compression scheme because I told it that it's a normal map, and it's using compression that's specifically tuned to make normals look good. So anytime you have a normal map, you're going to want to make sure that you pick the normal map specific texture settings. All right, let's switch over to Unity and take a look at the same kinds of settings, but in the Unity engine. All right, so here we are in Unity, and the first texture that we're going to be taking a look at is my color texture, cobblestones_D. That D stands for diffuse, by the way, but the texture can also be called albedo or base color as well. So you can see that my texture type is set to default. My alpha source is set to none because I don't have an alpha channel. And I have sRGB checked on because this is a color texture, just like in Unreal. And then down here under max size, I have my size set to 2048. And you can see that that gives me memory usage of 2.7 megabytes because it's using DXT1 texture compression. But I can also reduce this to 1024, for example, and hit apply. Now it's dropped to 0.7 megabytes, just like in Unreal. So the controls here are pretty similar. Now, one thing that's interesting about Unity is I'm going to have tabs here for every different platform that my game is currently configured to support. So right now, I have my game set up to be for PC and also for Windows, but I may have other platforms like Android or Apple devices or PlayStation, that kind of thing, and each of those will show up as a tab here. So I can set different size and quality settings for each different platform. All right, let's take a look at another example. Here's my cobblestones, my roughness texture. You can see that roughness is just a single channel, but it's also using DXT1, and it's using 2.5 megabytes. For my height map, let's take a look at that one. My height map is just 256, and I've set it to high quality here, which made Unity select the BC7 unorm format, and that got rid of the texture compression artifacts in here, but it increased the size, just like we were looking at in Unreal. All right, and finally, let's take a look at our cobblestone texture, our normal map texture, rather. So I've got my texture type set to normal map here, and you can see that it's chosen DXT-NM as the format, which is a format that's specifically made for compressing normal maps to get maximum quality. All right, so Unity and Unreal have a similar set of settings here for choosing the texture type, the texture size, and the texture quality. All right, and that's gonna about do it for us today. I hope this has been helpful for you in understanding the difference between source textures, raw textures, and in-game textures, and understanding the factors that go into the size of your texture maps in memory, from the resolution to the number of channels and the compression settings that you select, and that you've learned a lot about bringing in textures and setting them up to be correct, to be as efficient as possible. Next week, we're going to focus on linear interpolation. So I'm going to be teaching about how the lerp node works and showing you a bunch of tricks that you can do using the lerp node in your shader graph. So be sure to stay tuned and come back for that. And in the meantime, have a great week, everybody.